Okay, so what are chemical formulas again? If symbols are the letters of the alphabet, chemical formulas are the words. So chemical formulas are the words of chemistry. The words of chemistry. Chemical formulas are the words. They're going to tell us, number one, the element involved, and number two, how many of each element is involved. How many of each element is involved. So number one, what are chemical formulas? The words of chemistry. Number two, what does a formula tell you? The elements involved in the compound and how many of each element. You don't have to write down every word. Where are you? Thank you. Student service. Okay, so what are the three types of formulas? Ionic compounds, molecular compounds, acids. Ionic, molecular, acids. Ionic, molecular, acids. So, yesterday I taught you how to write ionic compounds using the lab. What are the characteristics of ionic compounds? Metal, non-metal. Metal, non-metal. Something on the left of the zigzag line, something on the right of the zigzag line. And you must always remember the metal goes first. The metal is always first. The metal is always first. Okay, so how do we name ionic compounds? The positive ion, the metal, just name it. First name comes from the metal. The second name comes from the non-metal with an IDE ending. You have to change the name to IDE. Now I know this is not as common as it used to be, but back 60 years ago, ladies, if you got married, what happened to your last name? You changed it, okay? So think of the metal as the guy and the non-metal as the girl, and that will help you remember that the girl's last name has to be changed to I-D-E. To I-D-E. All right, let's practice. I'm taking volunteers, and by volunteers, I mean like I'm going to volunteer you. So, Zach, I'm volunteering you. NaCl. What is the name? What is Na? No, it's not sodium. And what is Cl? Chlorine, but they just got married, so change it to fluoride. Emma, thank you for volunteering. MgN2. Magnesium nitride. Nice. Ryan, register. LIS. Lithium. Sulfur, no, sulfide. Sulfide. Sierra, thank you for volunteering. AL203. Yes. Oxygen? No. Oxide. Oxide. We good? All right. Iron 3 chloride. Iron, well, iron you know is Fe, and chloride you know is Cl. What's with the Roman numeral? Okay, so look on your periodic tables and you will see that some of the metals have multiple charges. For example, iron can be either 2 or +3. Guess what the Roman numeral is telling you? The charge. The charge. The Roman numeral will tell you the version that you are dealing with. The version that you are dealing with. Elaine, copper 1, give me symbol and charge. Christiane, tin 2, symbol and charge. Most people would say Roman numeral 2 is +2. Roman numeral 4 would be IV, by the way. Do you all know your top 5 Roman numerals? 1, 2, 3, and then you go backwards. 5, and then 1 less 5. Right. Iron 3. Canaan. Danielle, lead 4. How are we doing? Still okay? So, how do you write chemical formulas? Place the positive ion first, symbol with the correct charge. Look on the periodic table. You may have to look at the name, because if the periodic table says it could be 2 or 3, then you're going to need to look for a Roman numeral. Number 2, place the negative ion symbol second with the correct charge. If you see a Roman numeral that tells you what the charge has to be, ignore what the periodic table tells you. The Roman numeral, pardon the expression, trumps anything else. The Roman numeral is more important than what the periodic table tells you. Balance out the charges with subscripts or use the crisscross method. Let's do it. Let's see, we're to Reagan. Thank you for volunteering. Reagan, give me the symbol and its charge. Barium. Okay, nitride ends in IDE, probably somewhere on the periodic table. Walmart. If it ends in IDE, it's probably Walmart. If it doesn't end in IDE, it's definitely Costco. Polyatomic ion, yes. What? Yes, but Reagan's doing this. You can do the next one. N-3. Okay, I'll show you the way that I taught you a few minutes ago using, the little symbols, and then I'll show you a way in which you could do it probably in your head. You ready? Plus 2 minus 3. Which one do you not have enough of, Reagan? All right, so add another plus 2. Mr. Marino, can I just add a plus 1? No, no, no. It's all or nothing, okay? If you need more plus, you've got to take a plus 2. But Mr. Marino, that messes things up. Yes, it does. Because now what do you have too much of? So you need another. But that's still messed up, Mr. Marino. Yes, it is. So Reagan, what's the final answer? Correct. Is there an easier way of doing this, Mr. Marino? I don't know. Does anyone know an easier way of doing this? Yes. I think it'd be easier to explain it this way. What's the least common multiple between these two? And not necessarily. It is most of the time, but not necessarily the same thing. What's the smallest number that both of these will multiply into? Sorry. Thank you. 2 and 3. 6. 2 goes into 6. How many times? 3 goes into 6. How many times? A little easier. Let's try that this time with Elaine helping us. Copper Roman numeral 2. Elaine, go. Least common multiple between 2 and 1. 2 goes in 2, which are understood. 1 goes in 2. Any questions? Maddie, thank you for volunteering, and especially with this one because this one's really tough. Okay, aluminum. Al. Charge, 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 charge. It is. Yours does say +3 on it, right? Okay. So FIDE, IDE, probably on the periodic table. Yes, it is. Charge. Least common multiple between 3 and 2. Maddie? What will they both multiply into? The smallest number. 6. 3 goes into 6 how many times? 2 goes into 6 how many times? Final answer? What is it? Al2. Oh, she put a plus here. How do I feel about superscripts? I find them disgusting. The final answer should not have any superscripts. So Al2, S3. You put a superscript, it'll be automatically wrong. Automatically. Why? Because in essence, by having 3 -2s and 2 +3s, what happens to the charges? They cancel out. They cancel out. All right. Malachi, thank you for volunteering. Lead 4 oxide. Pb plus 4 O minus 2. AC, what would have happened if we had multiplied these two numbers together here? We would have gotten 8. Yeah, I know what you meant, but you have to be careful. I understand. I understand. But you just got to be careful because, no, that is a technique. And that technique works most of the time, but not all the time. And I want to make sure that everyone uses a technique that works all the time. And this one works all the time. Malachi, 4 and 2. What will both of these guys divide into, multiply into? What's the smallest number that both of these multiply into? What? 4 can't multiply into 2. Yeah, I know, but let's do it my way. So 4 can't go into 2. Can 2 go into 4? Okay, so what is the least? Can 4 go into 4? Can 2 go into 4? Okay, so 4 is the least common multiple. So 4 goes into 4 how many times? 2 goes into 4 how many times? Drop all the charges, just keep the subscripts. All right, let's go backwards. Robert, Na2O. Na, I'd look for it on the left side, sir. Sodium and oxygen becomes oxide. Good. Now question, is sodium only have one charge? Oh, okay. If it had multiple charges, we would need to use a Roman numeral. How about this one? Let's see, who has not volunteered? Thank you, Jasmine, for volunteering. Cu. Copper. And Cl is what? Chloride. Look on the periodic table. Is copper one of those that can be either one or one of two different charges? Ah, so guess what we need? Roman numerals. Okay, so how are we going to determine this? A little bit of, probably see it in your mind, which is fine, but this is how you do it on paper. You ready? Cut it in half. Positive side, negative side. This is what we're trying to find. That is our goal. Okay? 2 times -1, because that's the charge on chlorine, right? 2 negative 1s gives you a total of what negative charge? 2 negative 1s is -2. Okay? If the negative side is -2, what must the positive side have to be? +2. So you have 1 copper, right? Understood, 1. 1 times what will give you +2? Roman numeral 2. Yes, sir. You can do it in your head. I understand that. All right. Look at this one. Yes. Okay, that's a good start. Copper chloride. Now let's check to make sure that copper has only 1 charge. Does it have 1 charge or does it have multiple charges? So we're going to need to specify which copper it is. So, what's the charge on chlorine? Right side, next to the last column. Oh, there should be. -1. Okay, so if that's the formula, if 1 copper is offsetting chlorine -1, I think we can do this one in our minds. What is the charge on copper if it completely balances out -1? Yes. So we have to put a Roman numeral. Last question. Let's see, who have I not volunteered? Sam! How you doing? Okay, go, MG.
Yeah. Oh wait, no, I don't remember. Magnesium, phosphorus. Right? Yeah.
Are you going to be one of these, when you get married, you're going to say, no, I keep my last name? Actually, I will accept phosphoride, but it's just phosphide. Okay, Sam, very important question. Is magnesium one of those ions that have multiple charges? No? Okay, no. If the answer is no, then that's it. You're done. Yes, Kane. No, because phosphate would be something you buy at Costco. Okay? All right. I want to get that far and deal with Costco items on Friday. So let's. Okay, so talk to me about Costco. All right. When you buy anything at Costco, you have to buy it in bulk. You buy boxes of it. You buy a box. All right. So the elements that I call Walmart elements are the ones that are found on the periodic table, because you only get, they come in individual atoms. But look on the back of the periodic table. Look at the chart called polyatomic ions. That is what I call Costco, because there what you have are groups of atoms that work as one unit. So carbonate is CO3, CO3 -2. So the whole group has a charge of CO3 -2, has a charge of -2. So what are polyatomic ions? Groups of atoms that together form an ion. How do you write these? Same, except that you have to put the whole group down. You have to put the whole group down. And if you have more than one of those groups, what do? Put parentheses. The analogy is that of, if you go to Costco and you buy one box of something, they usually just let you carry it out. But if you have multiple boxes, they'll ask you, hey, would you like to have a box to carry it in? Well, think of parentheses as that box. You only need parentheses when you have more than one of them. Remember, Sierra, this PowerPoint is on campus, so you don't have to go through that much trouble. Where do you find the polyatomic ions and their charges? On the back of the periodic table, on your chemistry handout, what I call the chem out. On the chem out. How do you write chemical names involving polyatomic ions? You do not change the name to IDE. If you buy it at Costco, you leave the name just as is. If you buy it at Walmart, then you change it to IDE. But if you buy it at Costco, you leave the name just as it is. All right? Leave the name just as it is. Let's go. Na3PO4. Any volunteers? Thank you, Elaine. Na. What is Na? Sodium. So you put down sodium. Is sodium one of those things that has multiple charges? No. Okay, so no Roman numerals. No Roman numerals. All right, notice that PO4 is a group. That ought to tell you right there. Costco. Look for it. Is it there? Phosphate, what do you do with the name? Elaine, what do you do with the name? Leave it alone. OMG. Sodium phosphate. Is that it, Mr. Marino? That is it. Done. Done. Okay. Volunteer for the next one. Thank you, Kanan. Cu is what? Copper. Is copper one of those that has multiple charges? Ah, so let's leave a space here for a Roman numeral. OH looks like it's a group. So look for in Costco land. Doesn't matter. Look for in Costco land. Hydroxide. Does it matter that there's two of them? Nope. It's still called hydroxide. Doesn't matter. Doesn't matter. Okay, so let's think this through. Copper can be either 1 or 2. If hydroxide is -1, which one of these two must it be in order to balance out with 2 hydroxides? Copper 2. Let's do it the long way. You have 2 of them. You have 1 of them. Hydroxide is -1. Cut it in half. 2 times -1 is -2, which means the positive side must be +2. 1 times what is +2? +2. Any questions? Here we go. Volunteer. Thank you, Ryan. Oh, Mercury's weird. Mercury's really weird. There's 2 kinds. Which one's the mercury with the little 2 on the bottom? Try again. Look down on your periodic table instead of depending on your memory. Oh, it's not on your periodic table. Okay, Reagan, which one is it? The first one. Okay, give your periodic table to Ryan so that he can put this vital piece of information on there. So Mercury 1, Reagan. CO3, looks like it's a group. So you find it in Costco. What is it? Do you change the name in any way? Excellent, excellent, excellent. Ryan, register, back to you. No, you haven't had a chance to copy that vital piece of information. Thank you, Emma. What is that? Ooh, Mercury's weird, 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 weird. Which Mercury is it if it doesn't have a little 2 there? Mercury 2. Okay, OH, ooh, that looks like a grouping. Hydroxide. Not bad, huh? Not bad. Not bad at all. Any questions? Okay. Then let's go the other direction. Barium sulfate. Nope, nope. Somebody new is going to volunteer. I can just feel it. I can just feel it. Thank you, Maddie. Barium, symbol, charge. Charge. Sulfate ends in ATE. If it ends in ATE and ITE, guaranteed. Bet Sam's life on it. You know how valuable she is to me. Guaranteed. It's on the back. It's on Costco. Look for it. Sulfate is SO4 charge. -2. First question. Do the charges equal? Then you're done. Should you leave the charges? Absolutely not. You know how fanatical I am about that. I hate superscripts. I hate them with a passion. Yes. Because they don't belong there, and by me telling you so dramatically that I hate them with a passion, I'm hoping to drill it into your mind not to put them there. I could care less, you know, but they can't be there because if they are, then it's marked wrong. All right, a new volunteer. Thank you, Christian. Tin. SN, does tin come in multiple charges? Ruh-roh, I wonder which charge it is. How do you know? Oh yeah, the Roman numeral tells you. Hydroxide, IDE. IDE, nine times out of the 10 is a element, unless it's something like, oh, hydroxide, in which case it's not. So hydroxide is a Costco item that actually ends in IDE. Okay? OH minus 1. Okay, are the charges equal? Okay, they're not, so we're going to have to balance them out. How do we do that? What is the number that they both will multiply into? The smallest number that they both multiply into? The answer is, Christian, 2. 2 goes into 2 one time. 1 goes into 2 2 times. Okay, this is the wrong answer. Let's keep asking questions. Did you find this in Costco? Yes. Do you have more than one of them? So Costco will offer you a big box to carry your little boxes in it. The big boxes we call parentheses. So you need to parenthesize the box. Don't put the parentheses on the other side of the 2 because that doesn't mean anything. You haven't changed anything. What you're trying to say is that you have 2 of what's inside the box. Okay, Mr. Marino, well, why didn't you put a box on SO4? Because how many SO4s did you have? 1. So what does Costco do when you only carrying out 1 box? Buy, go away now. So you only use parentheses when you have more than 1. Any questions? No, Kanan, I'm going to get somebody else. I'm so happy you got these. Robert, thank you for volunteering. I appreciate your courage. Aluminum, symbol, charge. So fight ends in ITE. What is that telling you? Costco? Do the charges equal? What number will they both multiply into? 3, 2, 6. 3 goes into 6. 2 goes into 6. So Al2SO3, 3. Are we done? Do we have more? Did we buy it in Costco? Do we have more than one of them? So we need go. That's what I love about chemistry. Chemistry, I can use virtually any aspect of life to illustrate it. Biology, you know, once you get to brown algae, you're going, well, this is brown algae. This is what it looks like. It's brown. Okay. Iron 2 phosphate. I need a volunteer, volunteer, volunteer. You've already volunteered. Thank you, Joey. Iron, symbol, charge. Oh, Fe can be 2 or 3. Which one is it? How do you know it's 2? Yes, you're right. Okay, folks, you know, we're actually going to discuss rocket science. This ain't it. If it's 2 or 3 and there's a big fat Roman numeral 2 there, guess what it is? 2. All right. Joey ends in ATE, OMG. That tells you something. Costco or Walmart? All right, so. All right, are the charges equal? No. So we're going to have to find the smallest number that they both multiply into. 2 goes to 6. How many times? 3 goes into 6. So get rid of the charges because you know how much I abhor them, how despicable I feel that they are. Is that the right answer? What's wrong? PO? PO4. Not around the PO. Then you would be saying that you have 42 POs. No, you're not saying you have 42 POs. You're saying you have you have two PO4s. Two PO4s. All right.